Hello everyone. Let's continue with the question series on sinusoidal steady state analysis. Next question. A system with a transfer function y of s by x of s is equal to s by s plus p has an output y of t equal to cos 2t minus pi by 3 for input signal x of t equal to p cos 2t minus pi by 2. Then system parameter p is. In the given question, transfer function is given. Input and outputs are also given in terms of p. Then we have to find the system parameter p. Okay, now let's first write the transfer function. That is y of s by x of s. Let's denote it as h of s is equal to s by s plus p. Now we'll convert it into frequency domain, that is replace s by j omega. That is equal to j omega by j omega plus p. Now this h of j omega will have a magnitude, that is magnitude of h of j omega, and also an angle of h of j omega. And that will be equal to, what is magnitude of h of j omega? That is omega by root of omega square plus p square. Now the angle will be, the numerator, the angle will be tan inverse omega by 0. That is tan inverse omega by 0, that is pi by 2. And the denominator, it will be tan inverse omega by p. This will be equal to omega by root of omega square plus p square, angle pi by 2 minus tan inverse omega by p. So this is the magnitude of h of j omega and this is the angle of h of j omega. That is magnitude of h of j omega equal to omega by root of omega square plus p square, and angle of h of j omega will be pi by 2 minus tan inverse omega by p. Okay. Now given input x of t is, what is given input x of t? P cos 2t minus pi by 2. Okay, if sine or cosine input is given to a function, then the output y of t will be the same cosine function or sine function, but its amplitude will be multiplied by the magnitude of h of j omega and its phase angle will be shifted by angle of h of j omega. That is y of t is a constant into this function, that is p cos 2t minus pi by 2 with a phase shift of phi, where a is magnitude of h of j omega and phi is angle of h of j omega. Okay. Now, what is omega? From the given input, we can see that omega is equal to 2. Okay, now we'll substitute here. Then magnitude of h of j omega will be 2 by root of 4 plus p square. And the phase angle will be, angle of h of j omega will be pi by 2 minus tan inverse 2 by p. Okay, now we'll substitute for a and phi. This is a and this is phi. That is y of t equal to 2 by root of 4 plus p square into p cos 2t minus pi by 2 plus phi. This is y of t. But in the given question, y of t is given as cos 2t minus pi by 3. Okay. So now we'll compare these two equations. We find that 2p by root of 4 plus p square is equal to 1. Comparing these two equations, we get 2p by root of 4 plus p square equal to 1. Now we'll rearrange this, that is 2p equal to root of 4 plus p square. Now squaring, we get 4 by 4 p square equal to 4 plus p square. That is 4p square minus p square, that is 3p square equal to 4, or p square equal to 4 by 3. So we get p as root of 4 by 3, that is 2 by root 3. This is the required answer.